Hi guys, let me remind you that at the end of class you will have a quiz on these notes that are given. So please take some notes. Um, and then let's talk about what we did yesterday. Yesterday we actually divided items fairly when we had two players. So if we wanted to divide a piece of cake, then one person could divide the cake and then the other person got to choose. So as the divider, I'm going to be very careful to divide it into two pieces that I would be happy with either one of them. So I would not make one bigger or one smaller. I would like to, as long as I'm happy with how I divide it up, then it doesn't matter what the other person chooses. Well, now what we're going to do is we're going to look at what do we do when we have more than two players. Um, we still have a divider, and the divider will actually do step one, the division of it. The divider will be picked randomly. It says right there, it'll be picked randomly. And then the divider gets to divide the objects into equal shares. So write that down. The divider divides the items into fair shares. So we're going to make a note right here. The divider is happy with any of these pieces. Divider is happy with any pieces. Okay? So then what we're going to do is we're going to talk about bidding. So basically, if we divided up pieces of cake, the divider did anyway, the divider would divide up a piece of cake, then any of the other players or the choosers would come and they would create a list of, yes, I think this one is fair, no, I think this one is not, etc. So they get to create what they call a bid list. And so this is the choosers, or the other players, not the divider. The choosers create a list with everything they consider fair. Okay? And then we have to decide how are we going to then distribute this. And it basically will depend on the bid list. Okay, so first of all, so how we distribute it is going to depend on the bid list. So what does that mean? So basically we have three different ways it could happen. Both or all choosers declare different pieces. So they would have value in different pieces and it would be easy to divide that up. Okay, so choosers would declare different pieces. Okay, so that's one way that the distribution could happen. The other thing is the choosers could all want the same piece. So the choosers would all declare the same piece. Put an S there, okay? So basically and we're going to look at examples here that explain this, but basically the choosers would come in and they would say, after the divider had divided it all up, the choosers, the leftover people would say, okay, I really like this piece A. So we all could want the same piece is what that means. Or the choosers could declare more than one piece fair. So part C here, the choosers would declare more than one piece fair. So they actually might like two or all of the pieces that they would be happy with. So basically what you're doing is you're coming through and you're going to put a value on these pieces. So when I value them, the value depends on how many different ways we have divided them up. In this case, in this first example one here, so example one, we have three pieces, or we have three, we have the divider and two choosers, so there's three players here, okay? So with that, since there's three players, we would want to divide whatever it is. If we're dividing a piece of cake or a whole cake, we would want to divide it into three parts. If there's four of us, we would want to divide it into 4 parts. If there's 10 of us, then we would want to divide it into 10 parts. Okay, so if we look here, basically what we've done is the divider took this piece of cake, or the whole cake, whatever it might be, and divided it into 3 parts that they would be happy with. And since there's 3 people, they divided 100% by 3 and got 33.3%. You have to have 100% value in the whole set or the whole cake. So therefore, the dividers, all of their percentages will always be equal because they're happy with any of it. Okay, so now let's look. So chooser 1 came through, and chooser 1 looked at the 3 pieces and basically said that they really liked piece 1. They would value it at 65%. Piece 2 would be valued at 20%, and piece 3 would be valued at 15%. Okay, these 3 add up to be 100%. And now let's look at what chooser 2 did. Chooser 2 came in, valued piece 1 at 30%, piece 2 at 25%, and piece 3 at 45%. Once again, boom, boom, boom. 30, 25, 45 equals 100. And then here we are at the divider, 33.3, 33.3, 33.3. So now what are we going to do? Anything, any piece that is valued more than 33.3%, any piece that's valued more than that would be considered fair because you feel like you got your fair share of it. So in this case, this is the target, 33.3, because there's 3 of us. So now let's go and let's look to see. Of the pieces for chooser 1, do you see that this is the only piece, right here, that chooser 1 thinks is fair? Because it is more than 33.3%. And if we look down here, we look for chooser 2. Chooser 2, the only piece that is more than 33.3% is this piece. So therefore, chooser 2 would consider piece 3 fair. Okay, so this is what we consider our bid list, okay? Bid list. The pieces we think are fair. Write it down. The bid list. The pieces we think are fair. Okay, so now we actually go to the distribution, which is nice because if you look, chooser 1 had value in piece 1 and chooser 2 had value in piece 3. So therefore, it's easy to see that we should give piece 1 to chooser 1. We also should give piece 3 to chooser 2. And that poor divider, he gets the leftover. Well, guess what? He's the one that divided it where he would be happy with any piece, so he would get piece 2. Nice, everybody's happy with their piece. Now, that is when everybody values a different piece. The distribution is easy, 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 easy. Okay, so let's look here to basically let's look at example 2 here. Okay, each chooser bids, makes a declaration on the pieces that they value as fair. Well, once again, we have, let me slide this up a little bit. Do I need to slide it up? Yeah. Once again, we have 3 players, the divider and the 2 choosers. So therefore, it's going to be divided into thirds. Okay? Divided into thirds. So the divider then takes the items, whatever they might be, and divides it into 3 piles or 3 pieces that they would be happy with any one of the pieces. Okay. So then chooser 1 comes in and chooser 1 says, okay, I'm going to place value in these pieces. Piece 1, piece 2, yeah, I'm liking piece 2 better, and then piece 3. So if we look over here on the bid list, chooser 1 basically only has piece 1 that they really would consider fair because it's bigger than the 33.3%. So now let's go down and look at chooser 2. Well, what happens here? Chooser 2 places value of 45% in piece 1. Okay, so it's bigger than that 33.3%. So therefore, that piece is considered a keeper for chooser 2. Piece 2, they valued at 40%. So chooser 2 liked both of these pieces to think that both of these guys would be a good piece to have. It's bigger than the 33.3%. Since it's bigger than that, then these guys right here, so this bid list, chooser 2, would think piece 1 and piece 2 are fair. Right? Because they both value more than 33.3%. So now, how are we going to divide it up? How are we going to divide it? So let's go back and talk about it. First of all, the divider gets the one that's not chosen, but they're happy with it because they divided it into equal parts that are fair to them. But now let's look at these guys. Do you see that piece 2, both players have the same value in the this piece? So they both value at 40%. Well, chooser 2 has more value in piece 1. So therefore, chooser 2 should get piece 1 because they value it more. And therefore, it is fair because any 3 of these pieces are considered to be fair because they're bigger than the 33.3%. So therefore, we're going to say piece 1, write it down, goes to chooser 2. Piece 2, goes to chooser 1. So piece 1 goes to chooser 2. Piece 2 goes to chooser 1. So therefore, the divider is left, and they will be quite happy with piece 3. Okay? So, so chooser 2 would have been happy with 2 of the 3 pieces. And so they would be very excited that they actually got the one that they valued the most. And then chooser 1 is happy as well. Okay, So does it matter though that chooser 2 got what he considers 45% of the piece of cake or whatever we're dividing up, and chooser 1 only got 40%? Well, and then the divider got 33.3%. Does that matter that they're not equal? No, it doesn't. It doesn't say we're dividing them equally. It says we are dividing them fairly. And as long as each person feels that they get their fair share, everybody will call this a win-win. Okay, so now let's look at example 3. So still, we have our 3 players again. We had our divider and then our choosers, 1 and 2. So first of all, since there's only 3, this percentage stays the same, the 33.3%. Okay, so now let's look here. So chooser 1 places enough value to have a fair share in piece 1 because it's at 40%, not 20% because 20 is less than the 33.3%, but also would choose piece 3. Either one of those would be quite happy. They would be quite happy with. Chooser 2, on the other hand, looks at, they're excited about piece 1 and piece 3 as well. No, neither one of these guys wants piece 2, so guess what the divider's getting? Piece 2, and he's quite happy with it because he divided it into equal thirds, that he would be happy with any of these pieces. Okay, so, well, nuts. Now what are we going to do? Because both chooser and divider like both pieces. And so what would we do? So chooser 1 would be happy with piece 1 and piece 3. Chooser 2 is happy with piece 1 and piece 3. So technically, we could look at it one of 2 ways. You could flip a coin to decide who's going to get what. Or you could say, if I was chooser 1, I possibly would say, well, you know what? I like these pieces evenly. You like piece 1 a little bit more than I do. So chooser 2, you could have piece 1. But technically, and that would be the nice thing to do, but we don't have to do that. We could just flip a coin. So to be fair, we would flip the coin, and then whomever got piece 1, then the other person would get piece 2. In this case, I'm going to go ahead and I'm going to say, because chooser 2 values piece 1 a little bit more and chooser 1 values them the same, I'm going to give piece 1 to chooser 2. Okay, and then piece 3 to chooser 1. So therefore, the divider gets piece 2. And everybody's happy. Okay, so last example here. Last example. So, example 4. Now remember, guys, you will have a quiz at the end of class, so write these notes down. Write them down. So first of all, it doesn't tell me who the choosers and the dividers are. So if I look over here, I have Dave, Dylan, Devin, and Jacob. So I have 4 men, and they have divided something into 4 different pieces. So you have to be smart and tell me who the divider is. Well, first of all, since there's 4 of us, or 4 of them, it's going to be divided into fourths. So a fourth of 100 is the 25%. So if you look here, Dave is happy. He's got 25% of piece 1, 25% of piece 2, 25% of piece 3, and 25% of piece 4. So who's the divider? Ding, ding. It is Dave, because all of his percentages are equal. So now, bid list. Which parts or which pieces, sorry about that, which pieces do each of these players consider fair. So Dylan, anything that is 25% or bigger is considered fair. It's not 33.3% anymore because we're not dividing it into thirds. We're dividing it into fourths. So if I look at Dylan, then I see that he thinks piece 1 is fair. Does he think piece 2 is fair? No, he doesn't, because it's less than 25%. What about piece 3? Yes, because it's bigger than 25%. And he does not like piece 4. So Dylan is very happy with either piece 1 or piece 3, or S1 or S3, however you want to do it. So now Devin, let's come down here. And Devin, does he think this piece is fair? No, it's less than 25%. What about S2? Does he think that piece is fair? No, it again is less than 25%. And then what about piece 3? Ding, 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 look, he really likes that piece. He's placing it at 40%. So he thinks that's fair. It's bigger than the 25%, which is a fourth of the whole thing. And then piece 4, nope, it's not bigger than 25% or 25%, so he does not consider that fair. So Devin's bid list, he would then want piece 3. Okay, so now we go to Jacob. Does Jacob think piece 1 is fair? Is it a fourth of the whole? Yes, it is. It's a fourth of the whole. It's 25%. So Jacob, I probably just said Devin, Jacob right here is like, yes, I am happy with piece 1 because it is a fourth of the whole piece cake. What about piece 2? Nope, it is not 25% or bigger. Piece 3? No, it's not 25% or bigger. Piece 4? Yes. So Jacob here would be happy with piece 1 or piece 4. Okay, so now for the distribution. So we want to look and we want to decide who gets what. Okay, so first of all, if we look at Jacob, Jacob's biggest, his biggest percentage is piece 4. Did any of the other 2 choosers, not the divider because he's happy with anything, did any of the other 2 place value in piece 4? So no, it makes no sense for anybody to get piece 4 but Jacob. So you're going to come here and you're going to assign piece 4 to Jacob. Okay? So done. So now, what about, so Jacob's out. So basically he's got that. So now I'm going to mark this off. I would suggest that you mark it off with pencil so you can go back and see it. I did it in pen, so it would be a struggle if I had to go back and see that number. So now basically what I'm going to do is I'm looking at my other 2 players. So basically Devin here has the value in S3. He only values that 3rd piece. So therefore, any of these other 3 pieces he would not consider to be fair. Okay, so we would assign Devin piece 3. Okay, and then here, so Jacob got piece 4. Devin got piece 3, so now this is going to be out. And it does kind of stink a little bit because actually Dylan he valued piece 3 more than he valued piece 1. However, he still thought piece 1 was a fair share, so he still will be happy with this. He will feel like he got his fair share. Might not be his most favorite piece, but it's definitely a fair share. So Dylan would come around here and he would get piece 1, and then Dave, poor old Dave, the divider, he's going to get piece 2. He thinks it's fair because he divided it up. Okay, so what's different than what we did today and yesterday? Today, we're talking about more than 2 players. So you always have a divider. Pick the divider randomly. Flip a coin, roll a dice, whatever you might do. Rock, paper, scissors, whatever it is to pick your divider. And then have the other players or choosers make their bid list. And then you would go through and you would distribute the pieces to each player so they got their fair share. If it comes down to a tie, you always flip a coin. Don't let anybody else decide. Flip a coin to decide who gets what piece. Okay, guys, you're going to have time to do some classwork, but remember, you do have a quiz at the end of class.